So this is a bit of behind the scenes here, really. We get asked why the technical evaluations are, first of all, why they're mobile, and also why they're the size that they are when the HERU is only 600 by 600, which was the size of a washing machine, which is where we initially set out we wanted. This is for the domestic machine now. This is the 19-litre machine rather than the commercial machine, which would be 240 litres of capacity. So I'm going to just slide the front off and just give you a little bit more behind the scenes, so you can actually see the chamber here with the insulation around the chamber, and then at the bottom the heating element, which actually heats up the heat pipe and gets the pyrolysis going. So you will have seen perhaps a few videos of me actually putting material in, so I might not load it this time, but just bring your attention really to the actual chamber here and how you would you'd be loading the material in to the chamber. And one of the questions we get asked quite a bit is what happens to the gases and where do the gases actually go? So I really wanted to try and explain that a little bit. So here you'll see two letterboxes on either side of the chamber, inside the chamber, and when the material inside is heating up to 100 degrees centigrade, the moisture within that food and everything will be taken over the heat exchangers, and that water condenses and will go down the drain. The energy from the steam will go into one of these thermal stores that you can see behind me. Now what we're doing with this trailer is we're creating the entire home, if you like, or the business. So these water cylinders behind the thermal stores, they're holding the energy that we're creating. And then these two fans here, they're releasing the energy. So we're not connecting the energy during the field trials to the property. We're actually dumping the energy, which seems criminal, but it's all part of regulation until you're certified as an appliance. So as the gases, the temperature rises up to 220 degrees, you've boiled off all the moisture of course, and now pyrolysis is well and truly underway. And the oily vapours will follow exactly the same route. They'll condense on the heat exchangers, and then we wash them using these washing jets. And because we're under 372 degrees, we're breaking no hydrocarbons, so they're safe to flush down the drain. And then the gases, down here, I don't know whether you can see, but this tall tube here that I'm pointing at here is actually the water screen filter that we've developed and patented. And as the gases actually come out of the heat exchangers here, they'll then go down this stainless steel tube, up through the water screen filter, and we clean those gases. And as they come out of the water screen filter, they'll drop down into a cyclone, which we spin out the moisture, and then through a 5-micron filter, and then those gases will make their way all the way down the side of the trailer, right the way to the far end, and then pop up again where that blue cylinder is. And we'll pick up in a minute where those gases go from there. But let me try and explain a little bit also about why the machine looks bigger than it actually will be. These are all the electric cables that are coming to and from the HERU. And they then go up into this control panel here. Now this control panel will eventually become a printed circuit board, just like you would see in your washing machine or dishwasher or microwave. Initially they would have arrived from here because we've got a PLC here, a computer, and we can make software changes really easily by having this system. So we've been advised that we stay with this system until we haven't made a single software change for 8 months, and then that's the time to start thinking about a printed circuit board. Of course it drives a huge amount of cost out of the machine, but for us it's all about the detail with the programming and making sure, and we can dial into this machine from anywhere in the world and make a software change as we can with the other 2 technical evaluation units. So that's the electric side, and of course it takes up huge amounts of space that we won't need to have in the future. Then we've got the gas tank here, And we're always asked the route of where the gas goes, as I was saying to you earlier. And so the gas is sucked out of the HERU using this little 24-volt compressor. It stores the gas into here, and then when the gas, I've loosened this off, ready to show you inside. This is a Baxi 128 combi boiler, really clever boiler. It runs on LPG, natural gas, and also biogas. Really, really cool piece of equipment. And what we've created here is a Venturi. Now this Venturi, this silver pipe that you can see here is the mains gas coming in, or LPG as we are here. And then this copper pipe here next to it is the gas that's coming from the HERU. So when this tank here gets to 4.8 bars of pressure, sends a signal to the boiler to say, I've got some gas. The boiler then senses here using a UV sensor as to whether the boiler's lit and sends a signal back. That's creating a handshake. It's all safety systems, because we don't want to be releasing the gas from the HERU unless we're absolutely certain that the boiler's ready for it. Then the gas is released and it's blended then in through here into the combustion chamber of the boiler, and then this is the exhaust comes out of here. And that really then sort of deals with the whole gas system. And then we come back to the HERU, and we come to the washing system, because after we've gone through the process of producing the gas and also cleaning the gas during combustion, the chamber then goes into combustion phase after pyrolysis, and that happens by letting air in through this air valve into the chamber. We see the combustion running up to 450 degrees, burning the char that's inside, and then that gas, that's carbon monoxide, nitrogen oxides, they will actually come out and follow exactly the same route as the pyrolysis gas, over the heat exchangers, condensing any oily vapours, down through the water screen filter. Now we can take out the nitrogen oxides at this point through the water screen filter. We mix it using this here peristaltic pump, measures a little bit of detergent into the water system, and it's an alkaline solution, so it neutralises the acidity in the exhaust system, and takes out the nitrogen oxides and turns them into a nitrate. Nitrate's a fertiliser, so a valuable resource that can be recovered downstream. When I said downstream, I'm talking about the sewerage, obviously, connection, because then when we are connected to the sewerage system, we're offering advantages to that sewerage system. One big advantage is that on every combi boiler, there's a little white pipe at the bottom, and that drips sulfuric acid down the drain, and that's from the exhaust cleanup system. The HERU produces an alkaline solution, and so we can therefore help neutralise the acidity in the sewerage system. So the gases, then we've got the nitrogen oxides out, and we're now sending a carbon monoxide rich gas to the boiler. So now the boiler becomes a catalytic converter, and it's recovering the carbon monoxide, the unburnt carbon that's in that gas, and it's recovering that and turning that into energy and putting that into a thermal store as well. We're left then with a chamber with some ash in the bottom. So after the process, the machine cools down to 80 degrees centigrade, and then the washing system starts, and it's then flushing the ash that's into the system down through this pipe into a macerator and then down the drainage system. And the ash is really beneficial because it contains lye. Lye, if mixed with animal fat, is how soap was invented. It's the gritty substance in ash. We've taken the fat element out because we're recovering that energy, and we've also made it into an alkaline solution. And then the HERU then's ready for the next load. Just open the lid up and off you go again.